Alright, to start off with our complex numbers. Remember, complex numbers means imaginary. All up until today, when we've had a negative underneath the radical, underneath the square root, we've been able to write not real. But now we're going to have to go a step farther. What we need to know here is that I, that stands for an imaginary number, I is what we have when we have the square root of -1. Okay, to go the other way on that, if we squared that, I squared would be equal to -1. Okay, so those are the basis of what we're going to be dealing with on this. So, if I, yeah, you did. This is not new for us. If I saw the square root of -25, you don't have to do what I'm fixing to do. Zach, you need to go to the office. You don't have to do what I'm fixing to do, but this is the same as the square root of -1 times 25. Then the square root of -1 is I, and the square root of 25 is 5. I just sent Zach Dixon to the office. He was spitting a dip. He's got a dip. Bye. Alright, so you can skip that step. Anytime you see a negative underneath, you know you're going to have an I, so you don't have to write the -1, but that is what happens on that. Okay, so if I had here negative square root of -81, same thing except we got a negative out in front. I'm going to go underneath first, so that's going to be negative square root of -1 times 81. Square root of -1 is I, so the I gets to come out. Square root of 81 is 9, so I'm going to bring a 9I out, but then I had a negative in front. So that makes that -9I.
Do you hate this? This is the only thing I'm getting on.
Alright. So both of those that we looked at there were perfect squares. Now let's do some where they're not. Okay? So I've got the square root of -7. Okay, 7. Which one? 7, how does that break down? Okay, it is the square root of -1 times 7. Good, that's what Angie and Blake were both saying, because 7 doesn't have a perfect square that goes into it. So we can't do anything with that. So all we can do on this is bring the I out. So that would be I times the square root of 7. Alright, here I've got the square root of -44. Okay, so I know that's going to have a -1 in it. Now what about 44? Is there a perfect square that'll go evenly into 44? Okay, besides Blake, know it? 4, thank you, Betty. That's 4 times 11. Okay, we look for the biggest perfect square that'll go into it. Square root of -1 is an I, and the square root of 4 is 2. So I'll bring a 2I out. 11 doesn't break down, it stays in the house. Y'all remembering this pretty good?
Yep.
Good, 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 good. Alright, this next kind that we're going to look at is what tricked me initially. I had to look up a rule to remember because I was getting it wrong. It says the square root of -6 times the square root of -30. I'm writing the answer, dummy. Square root of -5. Alright, when I first worked this a long time ago, like not today or anything, but when I first started teaching this, I was writing the square, don't write this, I was writing the square root of -30. That's wrong.
Miss Simmons, can you please call the high school office?
Yeah, and I was like, well, doofus, it's because a negative times a negative is a positive. So I was writing the square root of +30, which is still wrong. Okay? What we have to do on this when we're multiplying, we got to take that I out first. Okay, so this would be I square root of 6, right? This one would be I square root of 5. So now I know 6 times 5, I know that is going to be the square root of 30, but what about the i's? What's I times I? Which, that's I squared, which is the same as -1. So my negative has got to go in front of that radical. It's really pretty basic. I was just being a bonehead when I was struggling with it. Take the i's out before you multiply them. Okay, so let's look. Got square root of -8 times the square root of -6. Alright, so we need to do the same thing. We need to take the i's out, but one of those can break down. So this, what's 8 with a perfect square? 4 and 2, very good. So that's going to mean an I that we just talked about. The square root of 4 is 2. So that'll be 2I square root of 2. Now I want to multiply that by, what about 6? Is there a perfect square that goes into 6? So all I can take out of that, since it's a negative, is the I. Okay? So what we're looking at on that, it doesn't matter which one, I'll do under the radical first. 2 times 6 is 12. Uh-oh, that's going to break down in a second. 2I times I is 2I squared, which that's going to simplify. So we can't circle this. There's still work to be done there. I squared is the same as what? -1, so that makes that -2. What perfect square will go into 12? 4 times 3. Okay, square root of 4 is 2, so I'll bring that 2 out. There's already a -2 out there, so what do I do with them? Multiply. You got it, dude. There you go. Did you say on Fuller House?
On Full House. Michelle, you got it.
I was about to say that came from the first one.
She was about to call you out, basically.
Yeah.
Yeah, but I would never give you chicken. I'm assuming it.
Fuller House is stupid.
Yeah, I've never even tried because you can't try to make Full House.
One time I was babysitting my nieces and they were watching it.
Fuller.
And I was like,
It's
a
on
9-year-old does not need to be watching this. It had some
Yeah.
stuff in it. It's not like that. Full House.
It's me. But you gotta make that's the show that we watched, which was Full House, and now the show that they're gonna be watching. Yeah, but it's
Yeah, but Full House was not
yeah, I know.
risky or whatever you want to say.
Yay.
Alright, this is a pretty simple one. Square root of -5 times the square root of 7. Okay, just wanted to show you what it'll look like when only one of them has an I. Okay, so neither 5 or 7, either one break down, so that's easy. Square root of the negative there brings the I out, right? But we don't have one over here, so it just stays square root of 7. So now I can multiply. You can multiply as long as the roots are the same. They're both square roots. So 5 times 7 is 35. So you just got your I, square root of 35. You'd be surprised how many people will put a negative out there, but you can't put a negative when it's just I to the first. Only when it's I squared can you put the negative. Alright, we okay? Okay, let's look at, those were all multiplication. Let's look at some division ones. I got the square root of -80 divided by the square root of -5. Now, just like I told you earlier, when I struggled on the multiplication, I forgot you had to take the I out first. You have to do the same on division. Okay, so we got to take the I out first. So I'm looking here, this would be square root of -1 is I. Is there a perfect square that goes evenly into 80? What? You're right, Leah. Tell me what.
Is it 4 times?
4 times 20, but there's a bigger one than 4. We're doing
16 times 5.
16 times 5. Very good. So now the square root of 16 is 4. So I've got 4i square root of 5 for my numerator. Okay, my denominator 5 doesn't break down. I just need to take that I out. So I'm going to take the I out, and then I still have the square root of 5. Now this is pretty easy here. Some pretty fun ninja math. Your square root of 5's divided by square root of 5's. They gone. I divided by I. So all I got left is
4.
Oh, you got it. Huh. Doesn't happen that way every time, but I like it when it does.
Yeah, I like it.
Alright, let's do square root of negative 40 divided by the square root of 10. Alright, so square root of negative 40. We know we got an I there, so I'm going to go ahead and do that. Anytime there's a negative underneath the radical, just write an I. That's what it basically boils down to. Biggest perfect square that go evenly into 40. 8's not a perfect square. Go back to your first one. 4 times 10. Square root of 4 is 2. So I got 2i square root of 10 over square root of 10. Now Angie had some common sense on that last problem. Since the last problem had a 5 on the radical on the bottom, she knew she was looking for that. So here, since this one had a 10 on the radical on the bottom, look for that. See if that's going to, doesn't always let you cancel out, but sometimes it will. So we got square roots of 10 again that are going to cancel out. So you just have 2i.
I looks up and backwards too, and I can't do that.
Okay.
Get mad at me.
Alright, these next kind are the easiest ones. One thing we need to know about a complex number. A complex number is in standard form when it looks like this. The first part is your real number, and the second part is your imaginary number. Okay, a plus bi, or it could be a minus bi, either one. A plus or minus bi. So when we have a binomial that's got a real number and an imaginary number, just want the real number first. That's basically what your standard form means there. So if I gave us a problem that said -1 minus 8i plus 9 minus 3i. This is the easiest kind because it's just like combining like terms. I got -1 plus 9, which is 8. Then I got -8i plus -3i, which is -11i. And that's all you would do. It's just like combining like terms. And that is in standard form because my real number's first and my imaginary part's last. Easy schmeezy. Okay, let's do one more of those. Is that what you need there? Good. I got -3 plus 2i plus 1 minus 3i. Okay, so I always just do my constants first, my plain old numbers. So I got -3, this is plus 1. So that gets me what? -2. Then on my imaginaries, I got 2i plus -3i. -i. And you can put the 1 if it bothers you. It's okay.
And normally, I normally have to, but
Alright, subtraction is the same. Let me just do one subtraction one just to make sure. I got -1 plus 2i.
Exact stuff and a lot of.
You'll have to bring me a slip.
Okay.
It's over there at that end of that table.
Okay.
You can bring me a slip, I'll get it. And be careful that bottle is in that bag that he was spitting in. You don't want it to spill in.
Run off and get it. No, there's, that's the one we have here. There's Scarlett.
Yeah.
Seriously?
Did he borrow, is that his charger or did he borrow? Anybody know?
No, I
Okay.
think it is.
Okay. Just want to make sure because y'all are always borrowing.
On Tuesday, to go to the office, and I was like, oh, what's going on with the office? And she told me, she's like,
He said he
Katie,
spit in
I
the
didn't
dip.
say it like that.
you were like, I just like get some kind of got a dip, he's dipping. I was like,
I was like, oh, go to that.
that's what happened.
Alright, so we got our subtraction problem here. Same as addition. We're just going to subtract like terms. -1 minus 4. -5. And then 2i minus 1i plus I. Okay? So we add and we subtract. We're alright?
We're good. We're
Alright,
gonna
that's where we're going now. Is fixing to multiply.
I thought we already did that.
Well, that was different.
That was with the radicals.
Oh, okay. Okay.
Alright, so here I got, start off with just a monomial, 6i times 4 plus 3i. So this one we've got just a monomial times a binomial. Okay, so all we're doing here is distributing. So I got 6i times 4, gets me 6 times 4 is 24, you stick your I there. And then I got 6i times 3i. 6 times 3 is 18, and I times I is I squared. Now you got to clean that up, because I squared, you know, is the same as what? So this makes 24i. I'm just going to, you're right, but I'm going to show all my steps. Plus 18 times -1, which Katie just said that makes that be minus 18. So 24i minus 18. Now I got to do one more thing to it. That's not in standard form because my real number's not first. So I need to switch it. Make sure you get your signs in the right spot. That 18 has got a minus, so it's going to be negative. I'll send somebody with it in a second. Thanks, Lisa.
Okay, you're welcome.
My 24i is positive, so it'll be plus. That'll be it.
I like this one better than what
Yeah.
we just did.
No,
No, like, the other one.
She's like, Addie, not pretty.
I don't think that was boring.
Alright, now let's do a binomial times a binomial. I got 3 plus 2i times 3 plus 4i. Okay, so I've got a binomial, and Katie's right on this. Binomial times a binomial, you're foiling. So my first 3 times 3, that gets me 9. On my outer, 3 times 4i, that's 12i. I can't write an I very good. On my inner, 2i times 3 is 6i. And on my last, 2i times 4i is 8i squared. Okay, start cleaning this thing up. On my middle, 12i and 6i. That's 18i. On this I squared, that's -1. So 8 times -1 is -8. 9 minus 8 is 1. That's in standard form.
Boom.
I'm just good at math. My dad's good at math. She said, I said I was good at math. My dad's good at math. I said something about working and doing good, and she said, "It's what you show us." But then I said it's okay, Shelby.
Ah,
You still love
Division. Division. Here we go. I got it?
Yeah.
6 plus 2i over 4 minus 3i. Alright, deal with this. It's just like a radical. Remember our rule, you can't, not our rule, but the rule we got to follow, you can't leave a radical on bottom. Same in a standard form of a complex number, you can't leave an I on bottom. So we have to somehow figure out a way to cancel that I out. When I have an I in a binomial or a radical in a binomial and I need to cancel it out, I'm going to multiply it by its conjugate. What's the conjugate? We talked about it in here before. Nobody remembers?
That's 4 plus 3i.
Very good. Everything stays the same. You just make your sign the opposite. Good job, Mr. Whitey. So I'm going to multiply it by 4 plus 3i. Whatever I do on the bottom, I got to do on the top. Okay, so conjugate, get rid of the bottom, just change the sign. So now that's FOIL on top and bottom. Okay, so let's get to busy. On my first on the top, that's 24. On my outer, 6 times 3i is 18i. On my inner, 2i times 4, that's 8i. On my last, 2i times 3i is 6i squared. Alright, so 18i and 8i, that's 26i. I squared makes that a negative 1, so times 6 is negative 6. 24 minus 6, 18. So this is my numerator. Okay, so hold on to that. I'll put it in a dotted box. Maybe I won't lose it. Okay, now I got to FOIL the denominator. Remember the goal, what we should see is i's cancel out. So my first, 4 times 4 is 16. My outer, 4 times 3i is a positive 12i. On my inner, negative 3i times 4 is a negative 12i. That's good news, right? On my last, negative 3i times 3i is a negative 9i squared. So here, 12i minus 12i, keep going.
With the 9 changed to a positive.
Yep. That I squared is negative 1, so negative 9 times negative 1 makes that a plus 9.
So then it's just 25 on the
So
bottom.
that's just 25 on the bottom. So we've got 18 plus 26i over 25. Now, I usually leave my answer like that, but that doesn't look much like the standard form because it's not split up. So on multiple choice, you're probably going to see this as 18 over 25 plus 26i over 25. Because that's what they mean, the same thing. That one just is more correct in standard form. All right, you're doing good. Hang with me. We got one more thing to talk about. Powers of I. Okay, last thing we got to talk about. Everybody got what you need here? If I said I squared equals, you would say negative 1. If I said I cubed equals, you say it again. Okay, I cubed is the same as I squared times I, right? Which is I squared is negative 1 times I. So that is negative I. Okay, we're going to make a list until we figure out a pattern. I to the 4th. So, since we know what I squared is, we want all this to be in terms of I squared. Okay, so I to the 4th would be I squared times I squared, which is negative 1 times negative 1, which is 1. Okay, I to the 5th. Can we do this now? Can I say I to the 5th is I to the 4th times I? Because I know I just figured out what I to the 4th is. So that's 1 times I, which is 1I. Okay. I to the 6th. That would be I to the 5th times I. And what was I to the 5th? I, right? Just look in the line above. So I times I is I squared, which is negative 1. Okay, let's go a couple more. I think you're about to figure the pattern out. I to the 7th. That's the same as I to the 6 times I. I to the 6 we just figured out is negative 1 times I. So that's negative I.
Really just like you did this.
Okay, so let's look at what we have. Negative 1, negative I. 1I. Negative 1, negative I. So what do you think I to the 8th is going to be? 1 I to the 9th. I, right? That, what? Yeah. Yeah. Looked at me.
So there's a negative 1,
So then,
positive 1, and then positive I.
Negative 1 and negative I. So the next two would be 1 and I.
Yes.
So you just keep going in that pattern.
Yes.
All of the ones that are odd had an I in it. Just had to figure out if it needs to be positive or negative. All the ones that are even have a 1. Just have to figure out if it's positive or negative. Okay? Alright, what you think? Okay, that was the last section out of this. Tomorrow I've got an assignment for you. We're going to do an assignment, get a grade on that. Friday I'll have your study guide for you. Test will be Tuesday. Got it?